Good morning, all of you. So, in yesterday's class, we have learned wires connected in series, and we have found effective Young's modulus. Effective Young's modulus. Now, today, two wires connected in parallel. Okay, two wires connected in parallel, and then in this also we will find out effective Young's modulus. Okay. Now let's consider two wires. This is a fixed support, and this is the first wire, and this one is second wire. Now we are connecting load to these two wires. Okay, this is load, and that is equal to W. Now this is first wire. Let us suppose Young's modulus of this first wire is Y1, and Young's modulus of this second wire is Y2. Let us suppose this area of cross section of this first wire is A1 and area of cross section of this wire is A2, and two wires are of same length. Okay, both are having same length, of course, otherwise load will not get distributed, hai na? So both wires have same length. So what happens when both the wires have same length? Strain produced in the two wire is same. Yes, so the strain produced in the both wires is same. Strain produced in the both wires is same, but stress will be same? No, stress will not be same. Okay, right? So therefore, can I say like this? Elongation produced in the two wires is same, but stress is shared between them. What will get shared? Stress is shared between them, and therefore net stress is equal to stress in wire 1 plus stress in wire 2. So net stress is what now? F by A effective. F by A effective or load by A effective is equal to F by A1 plus F by A2. Okay. Now, so this one is Y effective into A effective divided by L is equal to Y1 A1 by L1, but length is same, so we will take L only, plus Y2 A2 by L. Now this L I am cancelling throughout. So A effective is what here? Y into A effective. This I am substituting as A1 plus A2. Okay. What I am substituting? A1 plus A2. So this is A1 plus A2, which is equal to Y1 A1 plus Y2 A2. Note down this. This is effective here. And now next, Y effective is equal to this Y1 A1 plus Y1 A1 plus Y2 A2 divided by A1 plus A2, which I have transferred from this side to this. This will go at denominator. Now, if both wires are having same area of cross section, if A1 is equal to A2 is equal to A, then Y effective is equal to Y1 into A plus Y2 into A divided by A1 plus A2 means what? A plus A. So this is A I am taking common from numerator, Y1 plus Y2 total divided by A plus A 2A. Now this A and this A I am cancelling, and therefore in this case what is Y effective value? Y1 plus Y2 divided by 2. Okay, so like this. Note down. Yes, finished. Okay, so let's move for next topic. So next topic is, if a block of mass m is suspended with a wire of length L and uniform area of cross section at one end and other end is connected to a rigid support and is rotated in a vertical circle, The elongation of the wire when the mass is at highest and lowest position is means what here. So I am writing like this: block connected to one end of string and rotated in a vertical circle. Rotated in a vertical circle means how. Now suppose here let us suppose this is fixed support, and now this is a suppose block which we have hanged at this end. So let's take one block like this, okay, and this we have rotated in the vertical circle. From this point we have fixed this. And now this block is rotating, okay. So when at this end, that is bottom end, and when it is at top end, what happens? So when it is at bottom end, it has one velocity, and when it is at top end, it has some other velocity. Let us suppose at this bottom end, it has velocity v1, and at this end, it has velocity v2. Now at this point, what are forces are acting? This is mg, and in this string, there is a tension T. Tension T1. Okay, what is here? Tension T1, and down one is mg. And this length is what? L, from this point to this point. Okay, this, and this is fixed here. Okay, I'm writing like this. At center, it has fixed support, and it is rotating in a vertical circle. Now, at this point also, in this direction, you are having mg as well as tension, that is T2, and this side it is velocity v2. Now at lowest end, what happens? What is the tension at lowest end? Let's see. So at lower end, at lower end, T1 is equal to m phi1 square by L plus this m. What is this? Centripetal force. So at this end you are having tension T1. So if we will find out, or we want to find elongation L or E1, elongation E1, therefore elongation E1 due to this centripetal force and this weight is equal to F into L by A into Y. Here F is what? This complete. This F is what? This one. So therefore this E1 is equal to just this T1 into L divided by A into Y. Got it? So this is what at the lower end. Now when the ball will go at upper end, means here, what is the tension? It will get reduced, yes, or it will be less tension. So elongation will also less because block is above and string is down. Okay, so what is here? At upper end, tension T2 is equal to m phi2 square by L minus mg, and therefore elongation at that point E2 is equal to f L by Ay, which is common formula. And now at the place of f, I will substitute this T2 value. So this is just T2 into L by A into Y. Okay, just substitute the T2, you will get the answer, whatever this one is. One note point, if it just completes the vertical circle, if it just completes the vertical circle, then V1 is equal to root 5 GL, and this T1 is equal to 6 mg. This already in the rotational motion we have learned. Okay, right? Note down. Okay, finished. So let's move for next concept, that is elongation of the rod due to its own weight. What is that? Elongation of rod due to its own weight. Due to its own weight. Right. Okay. So in this, what we will do is we will consider a rod and we will fix it at one end, or we can say to the fixed support. Shall I draw here? Okay. Right. So this is the rod which I have fixed here. You can see. Okay. Now we did not hang anything to this rod. Okay. So just because of its own weight, what happens? It will give elongation. Yes or not? It gives elongation. Right. So see now what I am doing. Let us suppose the length of this rod is capital L. What is the length of this rod? Capital L. Yes. And area of cross section is A. A is what? Area of cross section. And this rod has m mass of rod, and due to its own weight, that is mg, it produces some elongation. Now let's assume that one small element here, length element, that is dx, which is at distance x from the bottom. What is this distance? X. And this length element, I will take with another color. I will show with another color. That is, this is dx. Okay. Now what happens here? So whatever the tension is getting produced in this rod at distance x from bottom, means at this point. So see, tension in the rod at a distance x from bottom is weight of this part. So let us give some name. This is P and this is Q point. So is T, and this is equal to weight of part PQ. What I am writing? Weight of part PQ. Rod part PQ. Now see, for L length, total mass is how much? M. Total mass is M. So for X distance, it will be how much? For X distance, it is how much? If we will do that, then how much we are getting weight? That is equal to M by L. M by L into this distance into this G. Okay, into this G. Yes or not? Okay. Now we got this tension T at a distance x from the bottom is this m by L into x into g. This is mass of this part and into this is g. So that is what weight, and because of this, this is nothing but what tension. Now suppose let dy is the elongation. Let dy is the elongation So dy is elongation in elemental segment dx. Then we have this strain is equal to, what is elongation? We know delta L by L is the strain formula, but here it is what strain? Dy. And what is segment? That is dx, right? Similarly, stress is equal to what? F by A. So for that particular segment, what we are having? T by A, because F is replaced with tension. Now Y, that is Young's modulus, Y is equal to stress by strain. Y is equal to stress by strain. What is stress now here? T by A divided by dy by dx. Okay. What is Young's modulus? Stress by strain, and therefore what we are getting? This T by A by dy by dx. So let's move ahead now. So I'm transferring this y into dy by dx is equal to T by A. So y and this dy, these two are different, Young's modulus, and this is what? Elongation is equal to T by A into dx. Okay. So what we got? Y into dy is equal to T by A into dx. Now what is T value? This one. What is T value? This one. M by Lx into G. Let's substitute here. So M by L into X into G into dx, and divided by A means I am taking A here only. M X, right? M by L X, है ना, into G is the tension value. Okay. And here it is Y into dy. So dy is equal to mgy into A into L into x dx. X dx. Right? Understood? Okay. Now let's integrate, because if we want total elongation y should be integration of dy, because all small elongations is equal to complete elongation. That's why we are taking integration. So here y is equal to integration of dy, which is equal to integration of mg by y a l into x dx. Now these all are constant, so I am taking out of the integration, out of integration, and that's why what we are getting, let's see, mg by y a l integration x dx. So limit of integration should be what? From this to this. So that's why I'm integrating from 0 to L. Now there is one formula of integration. Those who don't know, integration of x power n dx is equal to x power n plus 1 by n plus 1. Okay. What is that? X square or x power n dx is equal to x power n plus 1 by n plus 1. Okay, right. So now here x power n means x power how much? 1. So here it is mg by y into a into l x square by 2, because 1 plus 1 by 1 plus 1. And then this is 0 and this is l. So put upper limit, subtract lower limit. Mg by y into a into l. This is Young's modulus, okay? And this is another y. This is elongation. Keep it in mind. So this is L square by 2 minus 0 square by 2. So this we don't want. So only you are getting mg L square divided by 2y a into L. This is what? Small y, and this is capital Y. Because this is elongation, this is Young's modulus. So shall I write it with different color so that you will not mix it? So I'm changing that color to red. This red y means Young's modulus. Okay, this red one is there, no? This is Young's modulus. Keep it in mind. You also write little bit different, or you can make like this also, like this, something like this. Okay, this y and that y should be different. Like this you make. Okay, like this is Young's modulus. And now this L and this L will get cancelled, and this elongation y is equal to mgl divided by 2ay, mgl by 2ay. This is what? Elongation. Okay, or else even you can replace whatever you want. This y, that is elongation. Clear? Understood? So note down. Okay, finished? Right. So next, now see, now we got elongation y. I can write it as a e also, है ना? Y is equal to e is equal to elongation, which is equal to what we got formula? mgl by 2ay. Now I am multiplying and dividing by ll. So what I am getting? mgl square divided by 2y into a into l. Now a into l is again volume. So this is mgl square divided by 2 phi a into a nahi aayega hai na, a and l is phi. So only phi into y. What is that? Phi into y. Okay. Now this m and v, that is m by v, can I substitute as a density, because rho is equal to m by v, and therefore this elongation E is equal to rho g l square divided by 2y. Is also important formula. Okay, so let's solve one small problem on this only. So what is the problem? See, a 8-meter long string of rubber problem. A 8-meter long string of rubber having density 1.5 into 10 to the power 3 kilogram per meter cube, and Young's modulus 5 into 10 to the power 6 Newton per meter square is suspended from the ceiling of a room, is suspended from the ceiling from the ceiling of a room the increase in its length the increase in its length due to its own weight will be due to its own weight will be, and you can take again g is equal to 10 meter per second square. Can you solve it? Yes, very easy. What is given? Density दिया है 1.5 into 10 to the power 3 kilogram per meter cube. Next is y, 5 into 10 to the power 6 Newton per meter square. And next g is also there, right? L is also given. Yes, so L is equal to 8 meter, g is equal to 10 meter per second square. Rho we have, g we have, L we have, and y also we are having. Just substitute the values and do it yourself. Can you do it yourself? Yes. Can you do it? Capital L, say, because in the formula we have written capital L, no problem. Whatever you want. And therefore elongation E is equal to rho g L square divided by 2y. Just substitute the values and get the answer Answer is 9.6 into 10 to the power minus 2 meter. Answer is how much? 9.6 into 10 to the power minus 2 meter. Check it. Okay, you can check yourself and solve it. Right? So let's stop here for today. Bye.